Hello everyone! Today we'll talk about the solution to the problem maximum number of moves in a grid. When we read the statement and we parse these available moves, we'll notice that we can only move to the right. And we can either decide in our solution that we are going to use that fact, and in that case it's very typical when you can only move in a single direction, left to right or top to bottom on a grid, that the solution will be a dynamic programming solution, because in that case we can start in the first column and then we can calculate the best result we can get ending at a given column, and at every position we know that we could have come at that position only from those three options. For those we already have the result calculated. We only look at those for which the move is legal, as we have here, take the maximum of that, add 1, and this is the result for ending at the current cell. So if you like, you can solve the problem this way. However, a different approach, and an approach that doesn't use the fact that those moves are allowed only to the right, but instead uses the fact that for the move to be valid, the target cell has to have a strictly bigger value, which means that between two cells, only one direction can be possible for a move. So we know by just looking at two neighboring cells in which direction that move will happen. And in particular, that means that we can simply look for all the possible moves while remembering the pre-calculated results and arrive at the solution doing it like this, by just memorization. So in particular, we can just start at every position in our first column, because those starting positions are what we can look at, and we can look at every possible move. We can take the result that we can get starting at the position for that available move and take the maximum of those positions to be our result. This will be correct because, of course, there are no cycles, and it's this part that after moving the number has to increase, which allows us to make sure that we'll visit every position visit every position essentially once, or at most once. So, looking at the code for that solution, we have standard boilerplate. The only part that encodes the available moves is this part, which of course we always move to the next column, and the row can stay the same, or increase or decrease by 1. So this is also standard boilerplate. Typically we have 4 directions in grid problems. This situation here asks us for those 3 specific directions. And now we'll have essentially a cached function to calculate the result starting at any possible position. So essentially we'll be remembering the results that are similar to the DP solution that we've had. And of course the result is either 0 if there are no moves available. Otherwise we can make a move, and after making that move we can also make all the moves that are possible from the position that we're moving into. And the positions that we're moving into are of course our current row plus the change in row, column plus the change in column. Those changes are those 3 changes that we have defined here. We have to make sure both that we're still within a grid, so this is a standard check. Of course in Python you can check those inequalities in this concise fashion. And of course we can also, we have to check that the move is legal, so the number increases. The number in the target cell is bigger than the number in the current cell. And of course we take the maximum over all those and return it as the result. Since we can start at any position in the first column, we just take the maximum over the result calculated for every position in the first column, and that is simply the result. So this is a generator expression that will calculate the result for everything in the first column. So this works because the order for every cell to any given cell, to any given neighboring cell is defined. So the order of calculations is correct when we do it like this.